So I would like you guys to turn to page 21. Okay. So page 21 is about radical. So everything about simplifying square roots. So first thing, we need to know what kind of radical, right? What kind of question is considered simplified? Okay. So today there are two conditions. So we will just cover the first one today. So go to page 22. So if I give you give you a square root. So for example, like square root of 25. So, right, so for example, square root of 25. This one for sure is not simplified yet because I can turn it into 5, right? So something like this, if there's a perfect square on the inside, then we can simplify, okay? So this one is not simplified. Okay, if I give you something like square root of 17, right? This one, there's no perfect square on the inside, so this one is simplified. Okay, any questions so far? Right, this is a very simple rule to check if the square root that's given is simplified or not. But sometimes it's not that obvious. Okay, so look at one more example here. For example, I give you square root of 40, right? So 40, it doesn't seem like something times itself is can give you 40, right? Something square can give you 40. It's not possible. But if I break it down into 4 times 10, right? 40 is the same as 4 times 10. So even though 40 together is not simplified, but then inside of 40 we have a 4. As long as there's a perfect square, right? Perfect square. Just like 25, this is a perfect square as well, right? If you are able to find a perfect square on the inside, then the question is not simplified, okay? So this is not simplified. So not simplified means we need to do something to it, okay? So then it becomes simplified. Okay, so can you write these down in your notes? Okay, page 22. When you finish writing, you can raise your hand, okay? So we know we can try some questions. So our first condition is to make sure there is no perfect, okay, fill this in, no perfect square inside, okay, inside the square root, okay? Or if the question is a cube root, you want to make sure there's no perfect cube inside your cube root, okay? So if the question is a square root, then you want to get rid of this perfect square on the inside. If the question is a cube root, then you get rid of the perfect cube inside, okay? So write the notes down first and then raise your hand, okay? We're moving on to next page after this. Almost done? Brandon, Selena? Brandon, are you still writing? Brandon, are you there? Yeah, okay. All right, so the next page, we will have questions that are not simplified yet, okay? So we are going to learn how to simplify those square roots, okay, or cube roots. So let's look at page 23. So on the top, we have 3 examples which we'll go over together, and then you guys can try the bottom ones, okay? So for 180, okay, square root of 180. So we want to find all the perfect square that's hiding inside the 180. To do that, we do something called the prime factorization, okay? So we put 180 in the box like that, and then use only prime numbers to divide, okay? So the smallest prime number is the 2, because 2 is only 2 times 1, okay? So when you divide by 2, you get 90, and then you continue divide by prime number until you end up with a prime. So you can still divide by 2 and get 49, or 45, right? 45. Okay, what will be the next prime we can divide by? Waylon?
5.
We can divide by 5, very good. Okay, then you get 9, right? What's the next one we can divide by?
3.
Yeah, 3 is a prime. And then you stop at 3 because at the end, this is a prime, right? The final number is a prime, then you can stop. So what this is telling you is the 180 is made up by 2 times 2 times 5 times 3 times 3, okay? All the numbers on the side. Those are the factors that multiply together to make 180. So inside all the primes, okay, these prime factors, you get perfect square here, right? 2 times 2 is a perfect square. Okay, hold on one sec. Okay. Yeah, and then 3 times 3 is another perfect square. So those ones, when you square root, it will cancel each other out, okay? I will do it slowly first, okay? What I mean is that the 2 times 2 is like 4, right? So it's the same as having a square root of 4 times square root of 5 times square root of 9. 9 is from the 3 times 3, okay? Right, the 4 and the 9 comes from the 2, 2, 3, 3. So because those ones are perfect squares, they can cancel out with the square root. So you are left with 2 times root 5 times 3. So 2 and 3, they can multiply together, give you the 6, and then root 5. Okay, so it may seem a lot of steps here, but we can speed it up, okay, just by looking at the factoring. So I'm going to use the green color, okay? So when you are actually doing the question, just look for pairs. You have a pair of 2 there, right, in the green circle. You have a pair of 3 in the green circle. So you know the 2 and 3 are going to go outside. So you can go straight your answer to this step, right? Or even go straight to the final answer. So 2 and 3, they both go out. Multiply together, you get 6 on the outside. And then the 5 is left alone, okay, on the inside. Okay, any questions so far? So you just need to use the prime factor, right, and figure out what can go out. So let's try one more together, okay? So this time we're gonna do it faster. This is a cube root now. Okay, same thing, we want to use prime numbers. So can I have Marcus tell us what prime numbers to divide?
2.
Okay, what's the answer?
Um, 270. I think.
Okay, and then
2 again.
yeah,
That's 135.
very good. And then
5.
yeah,
That's 27.
very good. And then
3.
yeah,
9.
yeah,
And then 3 again.
yeah,
You get 3.
3. Okay, and we stop when it becomes a prime at the end. All right, so let's look for things that can go out. Okay, so Waylon, which number can go out?
2, a pair of 2 and a pair of 3.
How do you know we need to use pairs?
Because of the square root.
Okay, do we have a square root for this question?
Oh wait, never mind. 3.
Yes, okay, this is a cube root, right? So we need triplets. So which number can go out?
3s.
Yes, okay, so only 3 numbers that are the same that can go out, okay? Because that's 3 times 3 times 3 is a 27. It can break the cube root, right? So 3 goes out, and then you have a cube root. Be careful when you write the cube root, okay? Write small. So what number will stay inside now, Harry? Harry, what number stays in?
20.
20, okay. How do you get the 20? Can you tell us?
2 times 5.
Yes, excellent. Okay, so 20 left inside. Okay, so remember when you write your answer, okay, for your homework, please do not write it like this. Okay, your cube root, make sure, okay, it goes with the root. Okay, don't put it with the outside number. Okay, so that will be your final answer. So if it's a square root, you need a pair. If it's a cube root, you need triplets. Okay. Now, what if you have variables? Okay, variables are actually easier because they already tell you how many things there are. Okay, so for this one, we have a square root, right? So square root, the 8, we already know it's made up by 2, 2, 2. So we have pairs, right? For x to the 7, that means you have x, 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 4, 5, 6, 7, right? For y, you have 5. So 1, 2, 3, 4, 5. So you just find pairs. There's one pair of 2 that can go out. Okay, how many pairs of x can go out here? Jenny?
Sorry, what was the question?
How many pairs of x can go out for this one?
I'm not sure.
You know what pairs mean?
Yeah, like for the prime, for the factoring.
Yeah, like for example, for question A, right, you have a pair of 2, a pair of 3, right? Pair means there are 2 things that are the same, okay?
Okay.
So 2 and 3 can go out for question A, right?
Okay.
Yeah, so if you look at
So
how many pairs of x can go out?
3 pairs.
Okay, so 1, 2, 3, right? So those x will go outside. Now for the y, okay, Evan, how many pairs of y can go out?
2.
Yeah, very good. Okay, 5y's you can only make up 2 pairs, right? So those ones will go out, and you already have something on the outside, so they will all multiply together. Okay, so 2 will go out, x will go out, right? You get 3 x's go out, 2 y's go out. So what should be on the outside at the end? Braden?
It should be 2x to the power of 3.
It already has x to the 3 on the outside. So they will join together.
2x to the 6.
Yes, very good. And then
Y to the 3.
y to the 3, very good. Okay. And then we have square root. Now what should be left inside? Colin. Colin, are you there? Colin? What's
Yeah.
left inside?
2xy.
2xy, very good. Okay, so the green ones are the ones that cannot make a pair. Okay, they have to stay inside, stay at home, quarantine. Okay, so stay there. Okay, so that's the answer, right? So if I want to get to the answer more quickly, you don't really need to write it all out, right? This is just showing you that you need pairs. So by looking at the exponent, you look at 7, x to the 7, you know you can only divide by 2 3 times. So that means 3 pairs, okay? If it's a cube root, you need triplet, okay? So depending on the kind of root, okay, then you take things out. So for the following, I think I'll pick several questions for you to do, okay? We'll do everything on the left side, okay? First column. And then these two. And this one, okay? So we'll do these questions. When you're done, you can raise your hand, okay? We'll check these answers. 1, 2, 3, 4, 5, 6, 7, 8. 8 questions. Be careful when you read the question, okay? Especially for cube roots. If you look at question I, okay, this 3 is a cube root. Okay, it's not 4 to the cube, okay? So when they are close together, make sure you take a look whether the exponent is with a 4 or is it with the root, okay? If they want to write it as a root, as the exponent, it will be written like this. Then this is a square root, okay? This will be square root. Okay, please write this down, okay? This will happen in your homework, okay? So don't confuse the cube root with the square root. So these two are different, okay? Okay, please raise your hand if you're done. Okay, let's check the first few questions now. Okay, and you can also compare with the way I do the questions. Okay, maybe it can help you speed up the steps as well. So for 12, right, what can go out? Ivy, what number can go outside?
2.
Yeah, 2 can go out. Okay, so when we do the factoring, right, of course you can do 2, 6, and then 2, 3. So you see a pair of 2. What other ways you could do is you can think of it as, of course, you don't have to always use 2. If you use 4, that's also okay, right? But then you just need to keep in mind that the 4, it's made up by a pair of 2, right? 4 is a perfect square. So if you can do that, then you know the 2 can go out, left with the 3 inside. Okay, so you can also use perfect square to do the dividing. Okay, that will be a little bit faster when you are trying to factor big numbers, right? So for example, like 45, of course you can start with a 3, right? Or I can start with a perfect square, 9, right? 9 is a perfect square, so you left with a 5. Okay, if you use a bigger number, you use the perfect squares. So 9, that means what number will go out this time, Evan?
3 and 3.
Yeah, so 3 will go out, left with the 5. Okay, so it gives you the same answer at the end. So for 90, we can again use a perfect square of 9. So that makes a 3 to go out. Okay. And let's look at J. Okay, 250 is a cube root, right? Has a cube root. We need triplets. So Braden, have you done the question J?
No.
Okay, can you go over with me then? What number do you want to use to divide?
5.
Yeah, 5. Then what's left?
50.
50, and then?
Divide by 5.
Yeah,
10.
yeah, and then?
5.
Yeah,
2.
2. Okay, so what should go out then?
5.
5, right? The triplet of 5, they all go out, and what will be outside then?
10.
10, yes, okay. 5 goes out means the 2 on the outside, they multiply together. Don't forget to write cube root. So leftover is only 2. Okay, let's look at F. All right, so Marcus, for F, what can go out?
Uh, uh, I don't think anything can go for 75. I don't.
Did you break it down yet? 300?
Not yet. I couldn't find anything for 75.
75, if the ones digit is a 5, then you use a 5.
Oh, yeah.
Okay. Okay, I'll come back to you. Okay, you continue with that one. All right. For question I, okay, so 108. Okay, Colin, what can go out from 108?
I did 2, 2, 2, 3, 3.
Oh,
So
2,
it's
3, 3. Okay, so 54, 2, and then what? 27, 3, 3, 3. Right?
Mhm. Yep.
Okay, so what goes out then?
2 and a 3.
Both 2 and 3 can go out?
Wait, is this square root or cube root?
Well, look at the screen. What does it say?
Square root.
Okay, you look at the symbol, right? I wrote down cube root here. I know this one is a cube root because it's attached right above the root, right?
Oh,
The hook. If it's a square root, they will put it further apart,
oh, then
Okay.
only 3 goes out.
right? So for the question, it's a cube root, okay? Only
Alright.
3 goes out, so what should go outside then?
3.
3 goes out, but there's a -4 on the outside.
So it's -12,
Yeah, -12 will be left. And then
and then square root,
it's cube root.
cube root,
Yeah, cube root. And
4.
then 4. Yeah. Okay, so 4 left inside. All right. So now the letters. Okay, we'll look at the letters. For 75, okay, x5, y cube, z4. Okay, this is a square root. We need pairs. So Angela, what goes out?
Including the variables,
Yeah, including the variable.
5x squared, y, z squared,
Yes, very good. Okay, and the leftover,
3xy.
3xy. Okay, yeah, okay. Anyone has question how we get this one? You get pairs of 2 pairs of x, 1 pair of y to go out. And the z, once you take out the 2 pairs, there's no more z inside. Okay, and Selena, can you try question N?
Like, do I have to factor the 108?
Yeah, 108. You got to figure out what can go out from 108.
2, and then 54, and then 2. 27.
Okay, are you writing it down too?
Yeah.
Okay,
And then 3. 9. And then 3.
okay. So what does that mean?
Like you get pairs, right? So the 2 and the 3. So would that multiply? So that'd be 6.
Yeah, and
So
once it go out, it becomes
12.
12. Yeah, there's a 2 there. Okay, now the letters.
Does the M go out? So it would be like 3. Wait.
You're
I'm
looking for pairs, right? How many pairs of M can
there's
go?
pairs.
How many? Can you say again how many?
4.
4 pairs, very good. Okay, total 8. So cut into 4 pairs of 2. So M to the 4, okay? And then how about the N?
7.
7 pairs, okay? The outside already has 1, so
8.
Yeah, n to the 8.
And then p.
P. Okay, now we need to know what's still left along inside.
3 and 1.
Yeah, 3n to the 1. Okay, very good. Okay, and Brandon, have you finished question F?
F? Yes.
Yeah, okay. So what can go out for 300?
10.
10? Okay, very good. Pairs of 10, what's left?
Root 5?
Root 5, how'd you get 5? Can you tell me what numbers you have for the factoring?
2, 2,
Hold on,
5.
2, so 150, right? And then
2.
2. Did you use 2 next?
5.
Oh, you used 5? Okay. Then what's,
No, I used 2 on 150.
oh, okay, so 2. Then the answer will be 75.
Then I
And then,
used 5.
and then what do you get?
25. So it's just 5.
Not 25.
Wait. Oh no. 15.
15, yeah. And then
3.
3 and
5.
5, yeah. Okay, so you stop at 5, that's a prime. Okay, so what's outside then?
Still 10.
Still 10. What's left alone?
3.
Yes, okay, so leftover will be 3. Okay, another way to do the 300 is you can think about perfect square. You could use 100 because you know 100 is a perfect square. So 300 divided by 100 will be 3. So since it's a perfect square, you get a 10 to go out, 3 left alone. Okay, so if you are familiar with all the perfect square, you can also do it that way. Okay, so make sure you study this page before you do the homework. Okay, these examples should help you with the questions. Okay, I'll see you guys next week, and let me know if you have questions. Okay, bye-bye.
Thank you.
Okay, you're
Thank you.
welcome.
Thank you. Bye.
Bye.